Okay, this one's pretty easy, I think. You just got to study all the rules for position, velocity, and acceleration. So if this is position, again, velocity is the first derivative and acceleration is the second. So velocity would be 6t squared minus 30t plus 24. And acceleration would be the derivative of that, 12t minus 30. All right, so the initial position basically means what is this position when time is 0. So you plug in a 0 here, here, and here, and you get the initial position is 1. So they're on the x-axis at 1. Okay? What is the direction? Well, the direction is determined by velocity. If the velocity is positive, particle's moving right. Velocity negative is moving to the left. So for part B, I need to find the velocity at 2. So V of 2, if I plug in a 2 here, 2 squared is 4. So I'd get 24 minus 60 plus 24. I don't really care what that equals, except that it's negative. So since the velocity is negative, the particle is moving left at 2. Okay? All right, next, part C. When is the particle moving to the left? That just means do a velocity sign chart. So I'm going to set this guy equal to 0 and factor. Well, when I set it equal to 0, I think everything is divisible by 6, and that will make the factoring a little easier. So divide everything by 6, and you'd get t squared minus 5t plus 4. Factor that. Two numbers that multiply to negative or positive 4 and add to negative 5. And we get t equals 1 and 4. And now we have to do a velocity sign chart to find when the particle's moving left. So we're going to use velocity, do a sign chart at 1 and 4, okay? If I plug in a 2, then this is positive and a negative, so that's a negative. If I plug in a 5, we'd get positive, positive, plug in 0. Okay, so we're looking for when the particle's moving left, which would be when the velocity is negative, and that is from 1 to 4. Okay, last, what is the acceleration when t is 2? That would be the acceleration at 2. So that's 24 minus 30 or negative 6. It's kind of easy. Sorry, guys.